and I would like to almost remain online for
okay. Bye.
Have questions. So the first one is on ground contamination. On that basis, I would like to invite Hamza Saeed to come to the stage and talk about hydrocarbon contamination, something that happens a lot particularly in the Middle East area, and his perception of that. This will be a review talk. So Hamza, all yours, and yeah.
Thank you very much.
Thank you.
Good afternoon, everyone. So I would like to welcome you to my presentation, in which I am going to highlight the critical aspects of the hydrocarbons contaminations, which are mostly found in the soil, and their potential mitigation techniques. So here is the overview of my presentation. I have divided into 5 different phases, and here are the details. And especially, I have this image over there, which is basically approximately 33 years ago from Alaska, and still there are a lot of lessons to be learned from such disaster. So when we talk about the soil contamination, it's a globally recognized critical issue, and the major role players in the contamination are due to either hydrocarbons, heavy metals, or other organic and inorganic compounds. And we can see the scan electron microscope images of these compounds. So I will mostly focus on the geotechnical perspective of such contaminations. So when we talk about hydrocarbons, they are basically organic compounds, and they are existing in nature as either solid, liquid, or gas. And they are the simplest atomic structure, which is composed of carbons and hydrogen atoms. So hydrocarbons are further classified as aliphatic or aromatic, and we can see the examples in figure 4 for heptane as an aliphatic hydrocarbon and benzene as an aromatic hydrocarbons. So these are detailed classifications of the petroleum hydrocarbons by Ora et al. From 2017 article. So we can see that by far in 2022, the global crude oil production has an average production of about 0.94 billion barrels per day. And one of the major sources of contamination, as I mentioned earlier, is the hydrocarbons. And based on the data from the European Union, the major contaminated sites in the Europe are either from the heavy metal, which accounts for 33%, and 35% is for hydrocarbons. So generally, hydrocarbons are present as diesel, petroleum, or in most cases, crude oil. So basically, how does these hydrocarbons affect the geotechnical properties, especially when we talk about the 3 main properties, such as the morphological characteristics, in which the particle texture, particle-to-particle interaction, and especially the pore size distribution. And similarly, when we come towards the behavioral sciences of the soil, especially for the cohesive soil, the hydrophilic nature is basically turned into hydrophobic nature. And as you know, the clay soil has a strong affinity towards the water, which is completely turned into hydrophobic. So when the micro levels changes occurs, it directly affects on the macro levels, such as the shear strength properties. So when we talk about the hydrocarbons, heavy metals are also associated, especially when the oil refining is done. And these heavy metals are directly influenced on the, for example, if you take an example from the clay minerals, in terms of the exchangeable interlayer cations. And due to that, the pore fluid chemistry is changed as well. And on top of that, the soil fabric is completely changed, for example, into the flocculated structure. And in terms of the agricultural sciences, the pH levels are mostly affected. So the questions from this comprehensive review from the available literature that how these contaminants basically interact with the soil. So what are the primary triggers behind these interactions, and which are the most affected geotechnical properties from such contaminants? So I will discuss briefly in the upcoming slides. So coming towards the effect on microstructure. So as you know, the clay particle surface is negatively charged, and positive charged ions are attracted towards the surfaces. And when we talk about the hydrocarbon contaminations, unlike water molecules, they are not dipolar, and they cannot create a polar covalent bond with the clay particles. And as a result, we can see in the figure number 9b, the diffuse double layer is reduced, and at the hydrocarbon and clay interface. And this phenomenon lowers the water required to plasticize the clay particle, which is one of the basic properties of the clay particles, and thus it reflected directly onto the strength characteristics. So in this figure, the heavy metal concentration basically leads to the flocculation in most cases of the clay particles, which in turns what happens is that the repulsive forces are reduced, and due to these particle entanglement, it turns the stable solution into the unstable suspension. And we can see from the figure 12b that how it is comparable when at zero concentrations of the heavy metals in the clay soil. So similarly, when it comes to the cohesionless soil, as we know, the primary shear mobilization occurs due to the particle-to-particle interlocking. So if you see the 13a, the roughness of the particle is observed over there. But as the rate of the contamination increases, the particle surface is turned into more vitreous, or in other words, like glassy look-like material. So this one can directly affect on the internal friction angle of the soil. And in many cases, this reduction is observed even at the lower rate of contaminations. So here is the prime example between two particles over there. And as you can clearly observe that the particle surfaces are now being covered by the hydrocarbon film. So there is no particle-to-particle interlocking at all in the figure F over there. So in terms of the geotechnical properties, there are certain unanswered questions, especially after thorough literature review, that what happens to the internal friction angle? And but there is a certain consensus that in fact the cohesion is reduced in the cohesive soil, and the compressibility of soil increases significantly at some levels. But this is one of the prime examples from the data set we have collected, and I will only have shown the selected ones over here, that at low concentrations it increases, but suddenly after it decreases. Now, this unusual trend is basically linked towards the clay minerals, especially we know that there are three basic clay minerals, such as the carbonate, illite, and morillonite. And the carbonite has the lowest specific surface area and cation exchange capacity. And due to this, because of the less available negative surface charge, so the reduction will happen quite earlier as compared to the morillonite clay particles. So similarly, here is the variations of the compression index, and general trend which we can observe here is that it increases. And especially this is quite observable in the clay with high plasticity. So when the hydrocarbons are present, when the heavy metals are present in the soil alongside with the hydrocarbons, it mainly depends on the type of the heavy metal over there. So for example, in this figure for the unconfined compressive strength, at the 50 parts per million concentration, For the mercury, it showed the most increase in the, for example, unconfined compressive strength, but this is a temporary increase. So if there are other components present in the soil, this reduction will be evident. And also there are some conflicting findings in terms of the compressibility of soil in this case, because in some cases the compressibility was quite low for the heavy metal contaminations alongside with the hydrocarbons. So there are several mitigation techniques available. I will just briefly go through over them, but among those, bioremediation, electrokinetic stabilization, and the solidifications are more prominent in these cases. So for example, let's come towards the bioremediation. So in this case, from the name, the biological organisms are used to remove these environmental pollutants by metabolic process. So as from our first keynote speech today, it is basically a biomimicry from the microorganisms. So the oxygen is provided into the soil and the contaminants are pushed towards the other end, and the microorganisms decompose these contaminants. So similarly, when it comes to the electrokinetic treatment, it is basically a process in which begins with the providing the electrical field to electrode in various variations, such as, and it creates various reactions such as the electroosmosis, electrophoresis, electrolysis, and electromigration. In fact, our department, civil engineering department in the Eastern Mediterranean University, is quite active in this research, laboratory scale research, and there are publications in the recent years over there in this particular EK treatment method. So similarly, when it comes to the solidification process, in this case, the basic phenomena is that the solidifying agents are being injected into the contaminated soil. And these agents basically increases the binding between the contaminants and the soil and prevents the contaminants from spreading. In most cases, the cement-based solidifying agents are being introduced, but due to the nature of the theme as a nature inspired, so I think other aspects such as other techniques such as natural polymers can be a substitute to such solidification and the removal of the contaminants. So finally, I will conclude my presentation. I have highlighted the impact of hydrocarbons along with the heavy metals contaminant, how they affect the microstructural behavior and the geotechnical properties, and the remediation approaches for immobilization or removal of the contaminants. But at times, I will close this presentation by saying that if we are providing any solution, we have to also look into its field application as well. That this application is also on large scale or not, and other terms, is it going to be cost effective, and how effective is it going to be in a long-term solution. Thank you very much for your attention.
Thank you, Hamza. I've been thinking about that solidification, and when you said cement, obviously they're going to move away from cement, and you talked about natural polymers. It would be interesting to see how these range of natural polymers interact with different kinds of contaminants, and whether you are to what extent